Okay, this is a free response section, and part A, graphing calculator is required for this problem. Okay, number one, let's look at the table here. Okay, one, let f be an increasing function defined for x is greater than or equal to 0. The table gives the values for f of x as selected values of x. The function g is given by right here. Okay. So for the function g of x, they give you a function equation. And then for the f of x, we don't have function, but we have a selected values like that. Now, first one, the function h is defined, h of x is a g composite f x, or you can say g of f of x. Find the value of h of 5 as a decimal approximation, or indicate that it is not defined. Show the work that leads to your answer. Okay, so they ask you what is a h of 5. H of 5, same as just g of f of 5. And then if you have a composite like that, then you start from inside. So f of 5 is right here, right? That's a 34. So you substitute 34, so g of 34. Now g of x is that equation, so you substitute. So g of 34 should be equal to 34 cubed minus 14 times 34 minus 27 over 34 plus 2. Okay, and then calculator is required, so you can just type it in. So once you type it in, you will get around 1077.806. You have a more decimals, but in AP test, 3 decimal place is a standard. So I want to keep it like that. Okay, that's the answer. All right, second one, find the value of f inverse of f, or indicate it is not defined. Okay, how are you gonna find out f inverse of f? F inverse of 4, right? So that means it's like when y equals to 4, what is x value? So y is f of x. So when y equals 4, what is x value, right? So that's 3. So you can say just simply this one 3. Okay, you don't need to show other work. So that value is 3 from the table. You can say from the table. Or you can say since f of 3 equals 4, right? Now B, I find out all values of x as a decimal approximations for g of x equals 3, or indicate there's no such values. So you substitute 3 into left hand side right here. So 3 equals x cubed minus 14x minus 27 all over x plus 2. Okay, you can just multiply it out. You can solve for x, or since the graphing calculator allowed, so you don't need to do much like simplification. You just like graph this one in decimals and graph also this one and find out intersection. Or if you use like TI inspire, then you can just use a solve function, right? Then you can get x value. So x is, if you type it in, you got around 4.875, 3 decimal places. Okay. Now second one, determine the end behavior of g as x decreases without bound. So that means x goes to negative infinity, right? Because decreases without bound means negative infinite. Express your answer using mathematical notation of limit. So what is a mathematical notation of the limit? So you mark it this way. Limit x approaches to negative infinite. That's the mathematical notation of the limit of g of x, right? And limit x approaches to negative infinite. Your g of x, I just use this one. X cubed minus 14x minus 27 all over x plus 2. Okay. Now, how you gonna do it? This one, if you have a solve function and TI inspire, you can just type it in limit value, then you will get that value. Or you can do it by hand. For the limit, for rational expression like that, only leading term matters, right? So the rest of it you can kind of ignore. Then limit x approaches to negative infinite, x cube over x. That's basically limit x approaches to negative infinite. X cube over x means x squared, right? Now, so you substitute negative infinite into x, negative infinite square, that makes a positive infinite, right? So your final answer is positive infinite. Okay, let's move on. C, one, based on the table, which of the following function types the best models function? F, linear, quadratic, exponential, or logarithmic. Okay, let's look at the table here. That's a table of selected values. Okay, so based on the table value, let's look at it. So how much it increase here? So you add the 5, and here add the 9. That already shows that it's not linear because it's not a common difference. And this one you add the 13, and this one add the 17. Okay, so but we know that that's not logarithmic. Logarithmic is like, think about logarithmic is going this way, right? So as x increases, y value increase, but getting smaller. But this one is getting bigger. So I would say so far, either quadratic or exponential. But let's check your second row. So next difference, then that's add 4 here, and this one 4, and this one also 4. Okay. So second row is all 4, right? So if a second the difference in second row is a constant that shows a quadratic. Okay, so answer for this one, quadratic function. Now give a reason for your answer in part C, 1, based on the relationship between change in the output values of f and change in the input values of f. And then refer to the values in the table in your reasoning. Okay. So you can say how you, okay, they ask you how you come up with quadratic. So you can say, okay, the second differences are constant, right? Constant. In this case, it was a positive 4, right? It was a 4 over the consecutive equal lengths input values interval. Values intervals. Okay, then a quadratic model is best, right? Quadratic model is the best. Okay, that's the proper reason. That's a justification. Or you can say, in other words, you can say the change of average rate of change are same, right? Change of average rate of change is the same. So what does that mean? Average rate of change is this, right? So change of average rate of change is this, right? So they are constant, then it's also quadratic. Now number 2, students who completed a class participated in a year-long study to see how much contents from the class they retained over the following year. At the end of the class, students completed an initial test to determine the group's content knowledge. At the time t equals 0, the group of students achieved the score 75 out of 100. So that's the beginning. And then for the next 12 months, the groups evaluated at the end of each month to track their retention of the content. After 3 months, so which is a t equals 3, the group's score was a 70.84. So they lost some, they forgot some of it, right? So they only got 70.84. Now, group's score can be modeled by the function R given by this natural log function like that, where R of t is a score for months t, and the t is a number of months since the initial test. Okay, so we get that. So those are 2 points, you can write it down, 0, 75, and the other point is 3, 70.84, right? Those are 2 points. Okay, first one, A1, the first one. Use the given data to write two equations. Write two equations, that's the question. Can be used to find the values of A and B in the expression for R of t. Okay, so you just substitute. Instead of R of t 75 equals A plus B, which is unknown, and then ln of, you substitute 0 into t, so ln of 1, okay? That's the first equation. Now, second equation, 70.84 equals A plus B, and then ln of 3 plus 1 is 4, right? So that is answer. They ask you just write two equation, okay? That's the answer for I. Now, second one, find the values of A and B as a decimal approximations, okay? We know ln 1 is a 0, this one. So B times 0 is a 0. So that means we already know A is a 75, right? And then you substitute this one into second one. Then 70.84 equals 75 plus B times ln 4, right? So B value is 70.84 minus 75 over ln of 4. So once you type this one in the calculator, then you will get B is approximately negative 3. I already put in the calculator ahead of time, 0.00081. Okay, so that's the answer for A and B. So, okay, let's move on. Now, B, use the given data to find the average rate of change. It comes out very often in AP Precalculus. In months per month, in points per month, and from t equals 0 to t equals 3 months, express your answer as a decimal approximation. Show the computation that lead your answer. Okay, and then okay, so let's do that. So average rate of change is basically R of 3 minus R of 0 over 3 minus 0. So that's the average rate of change. So and then what is R of 3? So let's complete what was a R using this one here. We already found the A and B, so I can write here. Your R of t was, A value was 75, P value negative 3.00081, and then ln t plus 1. So that's my R of t. So if you put in the calculator R of 3, right? So you put 3 here, right, into t. Out of 3, if you put in the calculator, that you should get 65.84, and then once you put a 0, that's just then should be 70, right? That's a 70, and now you divide by 3, okay? Divide by 3, then you will get 1 second. So yeah, so then you will get around negative 1.387, okay? And the unit is a point per month, okay? That's the answer. So that's the average rate of change from 0 to 3, okay? All right, so let's move on. Now interpret the meaning of your answer in part B1 in the context of the problem. So what does it mean here? What does it mean? So you can say, this one every month they're gonna lose. They're gonna, they get less point that much every month because they're losing some of the contents, right? They learn. So you can say from t equals 0 to t equals to 3 months. Okay, the group's score decreases, right? Decreases at a rate of 1.387 points, right, per month. Okay, that's what it meant in the context. Now, third one, consider the average rate of change of R from 3 to P. P is greater than 3. And this average rate of change less than or greater than the average rate change from 0 to 3 months found in part BI. Explain your reasoning, and your expression should include the reference to graph of R. Okay, graph of R. Remember this graph of R? So that looks like that's like a negative ln, right? Remember the graph of ln is like this, right? But negative ln graph looks like this, right? So it's going that way. So start from like 75 and then it's going down, right? Like that. So you can say, so it's like this, then from 0 to from like 0 was like around, let's see, it was 70, I believe that's a 70, let's see, ln 0, ln 1, so ln 1 is a 0, so that's a 75. Actually this is also 75. So from 75 here, and then it goes down here, let's say this one 3, and then this one here is let's say p value. So what is the average rate of change? So basically slope of 2 secant line here, right? And then p is at any point greater than 3, right? So in here, so like somewhere here, let's say, then this slope, that's a average rate of change, that should be greater, right? Because a negative slope is less steeper, that means that's a greater. So the answer for that one, so you have to say average rate of change is basically increases, right? So you can say the average rate of change from t equals to 3 to t equals to p, right? That one is are increasing, right? Increasing as t increases. Okay, because this one is less steeper, and then for the smaller value for negative value, then increase, right? So that's the answer. Now C, the readers of study decide to use a model R to make predictions about the group's score beyond the 12 months. Okay, and then for a given year, model R is an appropriate model if the group's predicted score at the end of the year is at least 1 point lower than the predicted score at the end of the previous year. Okay, so key is at least 1 point lower, then it's valid. So based on this information, how many years of model are appropriate model? Okay, so then you can calculate actually using the out of t we found here. I'm talking about this one here. So you can just type in the calculator. So what you need to find is let's say the first 12 months, and then the second year's 24 months, right? So out of 24 minus out of 12, right? So checking the second month, I mean the second year is still valid. So that absolute value, so let's find out, right? So then if you calculate it, I'm not going to actually calculate it because you can just use a calculator and then put t equals 12 and t equals 24, right? So their difference you will see is a 1.962, which is greater than 1, which is good. It said that at least it should be 1 point lower than the previous one, right? So their difference is greater than 1. That means it's good. Now, when you check third year, which is third year means 34 months, right? 36 months, right? 36 minus R24. So that's the difference between second year and third year. Their difference. Also, same thing. If you put in the calculator and then find out their difference, then you'll get 1.176, which is greater than 1, which also valid, right? That's appropriate. Now, let's do fourth month. So this is up to third year. I'm sorry, that's a third year and this one second year. So fourth year, right? Out of 48 minus out of 36. So once you put in the calculator that values, you will get a little less than 1, which is 0.843, so which is less than 1. That means it's not good. Okay, it's not valid anymore. So question is, for how many years the model R is appropriate? So you have to say the model R is appropriate for 3 years. Okay, because fourth year, as you see here, their difference is less than 1, which is not valid. So model R is appropriate for 3 years.